So, hi, good evening. I'm Emmeline Joyce Ramos, and for question number 2, state 1 for a dual combustion engine is P1 is equals to 1 atm and T1 is 60.3 degrees Celsius. RK is 18. At the end of the constant volume combustion process, the pressure is 7,695 kilopascal. Okay, based on 1 kilogram per cycle of a hot air standard with K is equals to 1.31, determine the percentage clearance, PV and T at each corner of the cycle, W or the work, the efficiency, and the mean effective pressure. So, of course, first, we must determine the different given. So we have here the initial pressure, which is 1 atm. We have here the initial temperature, which is 60.3 degrees Celsius. We have here the RK, which is 18. We have here the P3, which is 7,695 kilopascal. We have here the RC, or the cut-off pressure, which is 1.5. We have here the mass rate, which is 1 kilogram per cycle. We have here the K, which is 1.31. So first, for the first unknown, first let's identify the different unknowns. So the first unknown is the percentage clearance. The second is PVT at each corner. And for C, we have the work. For D, we have the efficiency. And for E, we have the mean effective pressure. There. So first, let's solve for A, which is the clearance. So we're going to use the formula that RK is equals to 1 plus C over C, wherein RK is 18, 1 plus C over C, therefore C is equals to 18, 1 plus alpha x over alpha x. It is still loading. There. It is 0.0588 times 100%, which is C is equal to 5.88%. So this is the first unknown. For the second unknown, so we have here PVT at each corner. So PVT at each corner. So we're going to use this formula, or the equation, ideal gas equation, which is PVMRT. This is to solve for V1. So therefore V1 is equals to MRT of 1 over P1. Therefore the mass is 1 kilogram and the R is 0.28708, if I'm not mistaken. Kilopascal meter per kilogram degrees Kelvin times 333.45 degrees Kelvin. 333.45 degrees Kelvin. Before I forget, if you can see this came from the given temperature, which is 60.3 degrees Celsius. So, the degree Celsius converted it into Kelvin, therefore, it came up here. We're in 60 degrees, 60.3 degrees Celsius, plus 273.15. Here it is. Over the initial pressure, which is 180 m. And in 180 m, there is 101.325 kilopascal. Therefore, our volume is 1 times 0.2808 times 333.45 over 101.325. So there. The volume is 0.9448. 0.9448 cubic meter. So for at point 2, so P1 V1 equals to MRTs of 1. Oh wait, I think we can now use this formula, which is V1 over V2, wherein V1 is, therefore RK, the given value of RK is, wait, let me see, 18. And V1 is 0.9448 over V2. Therefore, V2 is equals to 0.9448 OPEX. Shift solve. There. It is 0.0525. 0.0525 cubic meter. There. For P2, let's see. For P2, we're going to use this equation. P2 over P1 is equals to V1 over V2 raised to K. But as we all know, V1 over V2 is equals to RK. Therefore, P2 over P1 is equals to RK raised to K, wherein P2 is equals to P1 RK raised to K. So, P2 is equals to 101.325 kilopascal times, the RK is 18, times the K is 1.31. Therefore, P2 is equals to 101.325 times 18 raised to 1.31. Here. 4,468.1073 kilopascal. There. Next is for T2. So we're going to use this equation. T2 over T1 is equals to V1 over V2 K minus 1, wherein T2 is equals to T1 RK K minus 1. Therefore, T2 is equal to 333.45 degrees Kelvin times 18 raised to 1.31 minus 1. Therefore, T2 is equals to 333.45 times 18, 1.31 minus 1. Here. 816.8930 degrees Kelvin. 168,930 degrees Kelvin. So Next is we have at point 3. So at point 3, V3 is equal to V2, wherein it is the value of this is 0.0525 cubic meter. So next is we're going to find on what is the value of temperature 3. So let's use this equation or this formula. T2 turns into T3 is equals to T2 P3 over P2. Therefore, T3 is equals to 816.833 degrees Kelvin times P3 is 7,600. If I'm not mistaken, wait, let me check it. P3. 7,000. There. 7,695 kilopascal over 4,468.107 kilopascal. Cancel. Therefore, T3 is equals to 816.33 times 7695 over 4568.107. Oops. There. 1,405.858, or it is 1,406.858 degrees Kelvin. So at point 4, we are going to find the value of V4, wherein we're going to use T4 over T3 is equals to V4 over V3, but RC is equals to V4 over V3. Therefore, V4 is equals to RC V3. And V4 is equal to 0.0525 cubic meter. So V4 RC is 0.0525 cubic meter times the V3 is 1.5. Therefore, V4 is equals to 0.0525 times 1.5. The answer is this, 0.07875. 0.07875 cubic meter. Next is for T4. So for T4, we're going to use this formula. T4 is equals to T3 RC. Therefore, 1,406.858 degrees Kelvin times 1.5. Therefore, T4 is equals to 0.858 times 1.5. There. 2,110.287. 0.287 degrees Kelvin. So at point 5,